So our lesson for today deals all about polynomials that we're going to factor to find roots and zeros. So quick review, if I give you a polynomial that's in factored form and I ask you to find the zeros. To do that, all you have to do is use that zero product property. We have three things here, three sets of parentheses being multiplied together, and we want to know when they equal 0. So all we would have to do is set them all equal to 0. So 3x minus 2 equals 0, x plus 1 equals 0, and x minus 7 equals 0. And we would just solve all of those for x to find the zeros. So the first one's the more complex. You would add 2 to get 3x equals 2, divide by 3 to get x equals 2/3. There's one answer. The second one, subtract 1 from both sides, x equals -1. And the third one, add 7 to both sides, x equals 7. So that's the easiest case scenario. You have three factors or more already factored for you. You just want to set them all equal to 0 to find your solutions. Find out what x equals. But what happens if I give you a polynomial that isn't factored? So down here at the bottom, we have x to the 5th minus 10x to the 4th plus 25x to the 3rd. Does anything stand out to you about this problem? What's that? What do they all have in common? They all have x's in common, right? So we need to take out a greatest common factor. So since they all have x's, I need to take out the smallest exponent on the x. So we have 5, 4, and 3. So we're going to factor out x to the 3rd. So if I factor out an x to the 3rd, that's going to leave you with x squared. So that first term, you had 5 x's, you're taking 3 out. Now you just have 2, so x squared. We had negative 10x to the 4th. We're taking out 3 of those x's, so now we just have negative 10x. With the last term, 25x to the 3rd, we're taking out the x to the 3rd, so we're just left with 25. So here we took out a greatest common factor. What do you think you're going to do with your parentheses there? So your parentheses is a quadratic, so you're going to use your asterisks. So in your asterisks, you have 1, top left, top right, negative 10 in the bottom middle, and 25 times 1, which is 25 in the top middle. So what two numbers multiply to give you 25, but add to give you negative 10? Negative 5 and negative 5. Perfect. Can I reduce either one of these fractions? No. So I'm going to go back over here to my problem. I still have that x to the 3rd. Don't forget it or leave it out. And now we have two new factors, x minus 5 and x minus 5. This is completely factored. So we've factored it. Now we can go through and set all three terms equal to 0. Ooh, I'm going to have to go over here. So I'm going to take x to the 3rd equals 0. And I'm going to take x minus 5 equals 0. Do you think I need to do the x minus 5 twice? No, they're both going to give me the same answer. So the x minus 5, if you add 5 to both sides, that's going to give you your first answer, or one of your answers. How am I going to get x to the 3rd down to just plain old x? How do I get rid of that exponent? Close. So it has an exponent of 3, so we want to take the 3rd root, the cube root of both sides. So the cube root and the cubed will cancel, giving us x. What is the cube root of 0? 0. So since the cube root of 0 is 0, x must equal 0. So in this case, we only got 2 answers because some of them repeated. So we're going to do some review of factoring because like I've told you before, factoring is never going away. Here we are week 4, and we're still factoring. So first thing we're going to review, difference of squares. We seem to be struggling with difference of squares when it comes up in a problem. So anytime you have two terms with a minus sign in the middle, I want you to check to see if both of them are perfect squares. Are both of these perfect squares? Yes, x squared, anything with an exponent of a 2 is a perfect square. And 16 is on our perfect square list. So I know this is a difference of squares. Two sets of parentheses, one gets a plus sign, one gets a minus sign. What is the square root of x squared? Well, the square root and the squared cancel, leaving you with just x. That x goes first in both sets of parentheses. You don't write both of them in the first set. You write one at the beginning of the first set of parentheses, one at the beginning of the second set. And then what's the square root of 16? 4. So 4 is going to go second in both sets of parentheses. Now that this is factored, we're going to use that zero product property, set them both equal to 0. So x plus 4 equals 0, x minus 4 equals 0. That's going to give you two answers, x equals negative 4 and x equals positive 4. Questions on this first one? Okay. I want you to see if you can do the second one. So the second one, you have two terms. I promise everything's a perfect square with a minus sign in the middle. So you're going to square root the first term, square root the second term, make your two sets of parentheses. So hopefully at the beginning of both your parentheses, you took the square root of 4x squared, the square root of 4 is 2, and the square root of x squared is just x. So at the beginning of both sets of parentheses, you should have 2x and 2x. For the second number or part of your factors, you're going to take the square root of 49. Square root of 49 is just 7. So your two factors are going to be 2x plus 7 and 2x minus 7. Set them both equal to 0. If I set the first one equal to 0, I'm going to have 2x plus 7 equals 0. Subtract 7 from both sides. So 2x equals negative 7. Divide by 2 to get negative 7 over 2. And as always, you can leave that as a fraction for me. You don't have to convert it to a decimal. The second one, you're going to take 2x minus 7 and set it equal to 0. Add 7 to both sides, so 2x equals 7. Divide by 2, and x equals 7 over 2. Questions on this one? So looking down at the bottom three questions, A, B, and C, is A difference of squares? No, we know automatically it can't be a difference of squares because there's three terms. So three terms, we want to factor this using our asterisks. So take a minute, factor that using your asterisks, write your two factors inside these parentheses right here. hopefully you wrote your two factors as x minus 6 and x minus 7. Order doesn't matter as long as you have them both. Then to get my zeros or my solutions, you're going to set both of those equal to 0 to get the two answers, x equals 6 and x equals 7. Letter B, x squared minus 9 equals 0. How should you factor this? A difference of squares. So they're both perfect squares. You have a minus sign in the middle. Square root of x squared is just x. So x is going to go first in both your parentheses. You know you're going to have one positive and one negative sign in your parentheses. And then the square root of 9 is 3. So you're going to have x plus 3 and x minus 3 as your two factors. If I set both of those factors equal to 0, I will get solutions or zeros of negative 3 and positive 3. So two solutions, negative 3 and positive 3. Letter C, how are we going to factor letter C? Yep, so they're both perfect squares, so you're going to use another difference of squares. So for the first term, I'm going to square root 4x squared. The square root of 4 is 2. The square root of x squared is x. So the first term in both my parentheses is going to be 2x. Then I'm going to square root the second term. The square root of 25 is 5. So my two factors are going to be 2x plus 5 and 2x minus 5. When I set both of those equal to 0 and solve for x, we get negative 5 over 2 and positive 5 over 2. Anything on this slide you want to see again? Moving to the next page, the second thing we're kind of struggling with is finding greatest common factors. So we're kind of using the distributive property backwards. We're going to take out what they all have in common, and then whatever's left is what goes into a set of parentheses. So for the first one, we have 4x minus 12. What can I divide 4x and 12 by? 4. So 4 is the greatest common factor. So it's going to go out front of our parentheses. And then to get what goes inside our parentheses, we're just dividing both terms by 4. So if I take 4x and divide it by 4, I just get 1x. And if I take negative 12 divided by 4, I get negative 3. So for that first one, we factored out a greatest common factor of 4. We ended up with x minus 3 that must go in parentheses. If we were asked to solve this, we would just set them both equal to 0. Well, 4 can never equal 0, so that one doesn't work. And then if x minus 3 equals 0, you would have a solution of x equals 3. For the second one, we have 4x squared minus 2x. What is our greatest common factor? 2x. Perfect. So I can divide both terms by 2, and they both have x's in them, so I've got to get rid of at least one of them. So I'm going to divide 4x squared by 2x. Well, 4x squared divided by 2x, 4 divided by 2 is 2. X squared divided by x is x. For this term here, we have negative 2x divided by positive 2x. Well, a negative divided by positive is negative. What are we going to write for 2x divided by 2x? 1. 2x divided by 2x. Same thing in the numerator as the denominator. it just reduces down to 1. That's no different than me telling you what's 2 divided by 2, just 1. X divided by x is just 1. The third one, 5x to the third minus 15x squared. What's our greatest common factor? 5x to the second, perfect. So 5x to the second or 5x squared is our greatest common factor. We're going to divide both terms by 5x squared. So first term, 5x to the third, divided by 5x squared. Well, 5 divided by 5 is 1. X to the third divided by x squared is just x. So you can either write 1x or you can just write x. For the second term, negative 15x squared divided by 5x squared. Well, negative 15 divided by 5 is going to be negative 3. And x squared divided by x squared is just 1. I don't have to write 3 times 1. 3 is just 5. For the last one, what's our greatest common factor? 2x. So I can divide every single term by 2x. So 4x to the third divided by 2x. 4 divided by 2 is 2. X to the third divided by x is x squared. For the middle term, if I take negative 10x squared divided by 2x, I get negative 5x, perfect. And then the last term, 4x divided by 2x, 4 divided by 2 is 2. The x is reduced to 1. 1 times 2 is just 2. Is this completely factored? No, you need to take this set of parentheses that we just got. Since it's a quadratic, you want to factor it further. So we're going to factor that using our asterisks. So a is 2, so 2 is going to go in the top left, top right. Negative 5 is going to go in the bottom middle. Be very careful. That top middle, you have to multiply a times c. 2 times 2, which is 4. So now I'm looking for two numbers that multiply to give us 4, but add to give us negative 5. Negative 1 and negative 4. Looking to see, can I reduce either side? Yes, the 2 and the 4 reduce. So if I divide them both by 2, I get 1 over negative 2. So I'm going to go back to my problem. I still have that greatest common factor of 2x, but now I have two factors. One of them is 2x minus 1, and the other one is x minus 2. So this down here is completely factored. Questions on these? All right, two more. So problems 1 and 2, or A and B, depending on where you're looking. So first one, we have x to the third plus 9x squared plus 18x equals 0. First thing I want you to check, is there a greatest common factor? Yes, what do they all have in common? X, they all have x's in common, so we need to factor out a greatest common factor of x. Whoops. So if I factor out a greatest common factor of x, that leaves me with x squared plus 9x plus 18. Can we factor the expression in the parentheses? Yes. So we're going to take the quadratic that's in the parentheses, use your asterisks out to the side, figure out what our two factors are going to be for that. So two numbers that multiply to give me 18, but add to give me 9, positive 6 and positive 3. Can I factor this any further? So neither one of the sets of parentheses are quadratic, so we probably can't factor it any further. So we're going to determine our zeros. To determine our zeros, we're going to set every single term that we have equal to 0. So here we have 3 terms. So we're going to set every single term equal to 0. Well, the first term is just x. So if I set x equal to 0, there's one answer. If I set the second set of parentheses equal to 0, x plus 3 equals 0, that's going to give me a solution of x equals negative 3. There's another answer. And the last one, x plus 6 equals 0, is going to give you a solution of x equals negative 6. So 3 answers. I know we're used to just getting 2 when we factor. Now we're adding on extra things. So here we had a greatest common factor that we had to set equal to 0. Look at letter B on the right side. I want you to figure out your greatest common factor. 2x is the correct answer. So 2x is the greatest common factor. So on your paper, I want you to factor out 2x from all 3 terms. Hopefully in your parentheses, you wrote down x squared plus 11x plus 30. Is this completely factored now? No. What do I need to do? I need to use my asterisk to factor what's in the parentheses. So that's a quadratic in my parentheses. So I'm automatically going to jump to my asterisk to figure out what my 2 factors are. And again, when I fill out my asterisks, I'm only using information from inside the parentheses. We're not doing anything with the greatest common factor, the 2x out front. Yep. So I'm going to use 5 and 6. 5 times 6 is 30, and 5 plus 6 is 11. So my factors are going to be x plus 6, x plus 5. Again, order doesn't matter as long as you have a 5 and a 6 in one of them. Now what do? Set them all equal to 0. 2x equals 0. How am I going to get x by itself? Divide by 2. What's 0 divided by 2? 0. There's one answer. For the second one, x plus 6 equals 0. What's x equal? Negative 6. There's your second answer. For the third one, x plus 5 equals 0. What's your answer going to be? Negative 5. Perfect. Oh, I circled them all in the box that one. So 3 answers, 0, negative 6, and negative 5. I'm okay with you leaving them like this. Sometimes I'll have people who write them as like x equals 0, comma, negative 6, comma, negative 5. That's okay too. So just so you're aware, there's more than one way to write your answer. Questions on this one? All right. Next two, looking at letter A in the middle, we have x to the third minus 36x equals 0. first thing you always check for is the greatest common factor. Do we have a greatest common factor? Do they have anything in common? No. Yep, they both have x's in common, so our greatest common factor is just going to be x. That leaves me in my parentheses x squared minus 36. What do I do with x squared minus 36? Perfect. That is a difference of squares. So difference of squares means I have my two sets of parentheses. One gets a plus sign, one gets minus sign, and I'm square rooting both terms. Square root of x squared is x. Square root of 36 is just 6. Can I factor any further? Nope, I'm going to set them all equal to 0. I'm going to have x equals 0 for this term. For this term, if I set x plus 6 equal to 0, I get an answer of negative 6. And when I set the third one equal to 0, I get positive 6. So 3 answers, 0, negative 6, and positive 6. The last one is 4 terms. Anytime you have 4 terms, you first want to check to see if you can factor by grouping. Well, first thing you want to check for is the greatest common factor. So in this case, there is no greatest common factor, so we are going to factor by grouping. Remember, when we factor by grouping, we're splitting the problem in the middle. And then we're looking for the greatest common factor of the left side. We're going to factor it out. And then we're going to look for the greatest common factor of the right side and factor it out. Yep, so on the left side, our greatest common factor is x squared. So we're going to take x squared out of x to the third to get x squared out of negative 3x squared to just get negative 3. So that's the greatest common factor of the left side taken out, leaving us with x minus 3 in our parentheses. If you remember from way long ago when we actually learned this, we automatically bring this sign down. So whatever our greatest common factor is, we want to make it negative. What's the greatest common factor of x plus 3? 1. So there's just a greatest common factor of 1. In this case, we're going to factor out a negative 1. So looking at those two terms, I have negative x, and I'm going to factor out a negative 1. That's like dividing this by negative 1. Well, a negative x divided by negative 1, those negatives will cancel. X divided by 1 is just x. If I divide positive 3 by negative 1, just gives me negative 3. If we've done this correctly, these two sets of parentheses should match exactly. Do they match exactly? Yeah, the signs are exactly the same. They're both x minus 3s. We're going to bring them down. What do I put in my other set of parentheses? X squared minus 1. These two things come down here. Have I factored this completely? No, why not? I got to do something else before I set them equal to 0. I have an x squared left. Anytime you get x squared left, you want to think, can I factor that further? Using what? Easier. Difference of squares. So that's a difference of squares. Remember, 1 is the smallest perfect square. So this actually breaks up into x plus 1 times x minus 1. Bring that x minus 3 down. So we use the difference of squares to break up the x squared minus 1 into x plus 1 times x minus 1. Thankfully, you don't see many problems this hard. Now, I don't have any squareds left. They're all just x's, so I want to set all my factors equal to 0. So if x minus 3 equals 0, x equals 3. If x plus 1 equals 0, I get x equals -1. And if x minus 1 equals 0, I get an answer of x equals 1. 3 answers, +3, -1, and +1. As always, order doesn't matter as long as you have all 3. Something new. I know some of you saw this on your knowledge assessment. This is the formula for sum and difference of squares. So this time we're going to have perfect cubes here and here. Really, the only thing that's different between these two formulas is the signs. So if you have a plus sign in the middle, you're going to use plus, minus, plus in your formula. These formulas will be given to you, so don't think that you have to memorize them. We just know that we have to know how to use them. So if we look on this next slide, we're asked to factor x to the third minus 64. First thing we always want to check for is the greatest common factor. Really?
Yeah.
You want to see if there's another packet back there that has it? Oh, does anybody else not have it?
I have it.
You got a faulty copy, I'm sorry. Sorry. I don't know how you got a copy without it. So first thing we're going to check for is the greatest common factor. There is no greatest common factor. So check that off. We're done with it. Then we want to rewrite this as perfect cubes. So I want something cubed minus something else cubed. Well, what cubed gives you x cubed? Just x. The tricky one is figuring out what cubed is 64. So easiest way to do this if you don't know is use your calculator. So grab your calculator. In your calculator, I want you to type 3, then hit your second button. Then you're going to hit your caret key. Remember, your caret key is just your upside down V. That means your calculator currently says 3 and then adds a little x and then your root. So that's the cube root. And then we want to type 64 in. And then hit equals. So your calculator is telling you the cube root of 64 is indeed 4. So 4 cubed is 64. That means that A and B, this is going to be A, and this is going to be B. So when I use my formula, whatever two numbers are letters, variables in this case, those two are going to be what I use in my formula. So in my formula, since the original here is minus, I'm going to use the second formula. So I'm using this formula right here. So I'm going to use A minus B times a squared plus ab plus b squared. And I'm just going to fill in A and B in the appropriate spots. Remember that A is just plain old x and B is just plain old 4. So for the first set of parentheses, I need A minus B. A is just x minus B is just 4. So the first set of parentheses is just x minus 4. The second set of parentheses is where things start to get a little bit more complicated. The first thing I want to do is take A and square it. Well, A is just x, right? If I take x and I square it, it's just x squared. For the middle term, I want plus a times b. Well, a is x, b is 4, so I'm going to take x times 4 to get 4x. Remember, it's customary to write the constant or the coefficient and then the variable. And then the last term is plus b squared. So I'm going to take b, which is 4, and square it. What's 4 squared? 16. You're done.
So if you keep it as 4 squared, you're gonna find out.
Half point. I promise this does not factor x squared plus 4x plus 16. Even though it's quadratic, it's not going to factor for you. There's not two numbers you can multiply to get 16 and add to give you 4. Let's practice another one. So first thing we're going to look for, greatest common factor. Again, there's not a greatest common factor, so we want to rewrite as perfect cube. So something cubed plus something else cubed. So you have to figure out what cube gives you 8 and what cube gives you 125. Calculator work all over again. So 3, shift or second, caret key, and then whichever number you're trying to find. So if you do the 8 first,
You said 3?
yep, so you're finding the cube root of those numbers. So if you're doing 8, you're going to type 3, second, caret key, 8, and then your equal sign. Your calculator does indeed tell you 2. And then the cube root of x to the third is just x. So then if you're doing 125, 3, second, caret key, 125. And that's going to tell you 5. Because 5 to the third is 125. So when we identify A and B, A is going to be whatever's in this first set of parentheses, in this case 2x. B is going to be whatever's in the next set of parentheses, which is just 5. So for this problem, we're going to use an A value of 2x, a B value of positive 5.
And how do you know which one to use?
Which one of the formulas to use? So if I look at my original problem, the deciding factor is going to be this sign. So since this is a plus sign, I have to use this formula at the top because it has the plus sign right here. So since those are both pluses, this time we're going to use this this formula right here. So we're going to use A plus B in our first set of parentheses. In our second set, we want A squared minus AB plus B squared. And then we're just going to plug things in. Remember, A is 2x. So first, term we have is 2x plus B, so plus 5. Our first set of parentheses is the easy one. You just have to bring A down, bring B down. So 2x plus 5 goes in my first set of parentheses. For my second set of parentheses, the first term, I want A squared. So I'm going to have to take 2x and square it. Well, if I square 2x, that means I'm going to take 2x times 2x. What's 2x times 2x? 4x to the second. Minus A times B. If I multiply 2x times 5, what do I get? 10x, perfect. Plus the last term, I want B squared. B squared means I'm going to take 5 and square it. 5 squared is 25. Perfect, you're done. Final answer, right here. Questions on this one? All right, let's look at the last one. Again, first thing we're always checking for is a greatest common factor. There is not one again, so we're moving on. We want to write this as perfect cube. So something cubed plus something cubed. Hopefully you remember from the last one, the cube root of 125 is 5. So we're going to have 5x in our first set of parentheses, which means a is going to be 5x. What about 1? It is 1. So the cube root of 1 is just 1 because 1 to the third power is still 1. 1 times 1 times 1 is still 1. So here we're going to use a b value of 1. Which formula are we going to use, the top one or the bottom one? The top one. Oops. Our original had a plus sign, so we're using this formula right here. I want you to take a minute, see if you can do it. So first set of parentheses is just a plus b. Second set, your a squared minus ab plus b squared. And again, you'll be given the formulas. You don't have to memorize them. You just have to know how to use them. When you get your answer finished, check it with mine on the board. Good job. So hopefully in your first set of parentheses, you have 5x plus 1. Your second set, the more tricky side, you should have taken 5x times 5x to get 25x squared. For the middle term, a times b, so 5x, the minus sign came from the formula. And then your last term, 1 squared is just 1. So that right there is your final answer. Questions on how to use this formula? Not going to do it very often, promise. All right, so something new. New as in we've never done it before in Algebra 2. So the rational root theorem gives a list of all the possible zeros of a polynomial. Blah, 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 we're not going to list this. So we're given a possible list. That doesn't mean that all of the list is going to actually be a zero of the function. There's the technical definition down here if you want to read through it. Really, all we're going to do is find out the factors of the constant term and find out the factors of the coefficient. Again, this looks really technical, but oh no, my stuff's going to fly. So here we're going to take this polynomial. If you look at this, it is 4 terms, but you cannot factor it by grouping. That's what makes this different. I can't split this in the middle and take out a common factor of 14 and 15 to make it a 2 and a 3. It's not going to work. So when factor by grouping doesn't work, we're going to have to decide the constant terms. What's that? Somebody said something. Oh. The constant term. So I want you to decide which one of these numbers is your constant, the number that's by itself. -2. So the constant term, whoops, is -2. So up here, the constant term is -2. The leading coefficient. The leading coefficient means go to the variable that's got the biggest exponent and tell me the number that's in front of it. 15. So far, so good, right? rational zeros, we need to take the factors of the constant divided by the factors of the leading coefficient. So really, we want the factors of -2, and we're going to divide that by the factors of 15. We're not ready for that yet. So we need the factors of this constant. So factors, you're going to go to your factor sheet. So if you have your factor sheet handy, pull it out. All the factors of 2, what are they?
1 and 2.
1 and 2. Keep in mind that I could take a positive or a negative version of either one of these. I could take +1 times +2. Actually, we have -2. So +1 times -2 to get -2. I could take -1 and +2 to get -2. So you're going to have plus or minuses in front of all of your factors every single time. Because again, if I'm trying to get -2, I could use a -1 and a +2, or I could use a +1 and a -2 and still get my -2. That's why we have that plus or minus. It's all the factors of 2, right?
Yeah.
On the bottom, I want you to look to find the factors of 15. 1 and 15, so plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. I don't know why I don't think. So this time we have 4 factors. That's okay. Are we okay so far? So we've identified the leading coefficient and the constant, then we've took the constant, all the factors of the constant, put them on top of a fraction, all the factors of the leading coefficient on the bottom. Then we're going to figure out all the possible fractions that can be created. So first one we're going to focus on is this 1. I'm going to take 1 and I have to divide it by all 4 of these. So I'm going to have 4 different answers. What's 1 divided by 1? 1. So the first possible answer is plus or minus 1. Because 1 divided by 1 gives me 1, right? So that was this. Then we're going to go to 1 divided by 3. So plus or minus 1 divided by 3 is just 1/3. We're going to leave it as 1/3. Then we're going to take 1 and we're going to divide it by 5. Does that reduce? No. So we're just going to have 1/5. And then the last one in the denominator that we need to divide 1 by is 15. Does 1 over 15 reduce? No. So we're going to leave it as 1 over 15. Guess what we're going to do with the 2 that's on top? The same thing. We're going to divide 2 by every single thing in the denominator. Let me switch colors. So now I'm going to take 2 and I'm going to divide it by 1. What do I get when I take 2 divided by 1? 2. Plus or minus 2. No need for a fraction there. Because 2 divided by 1 is just 2. Then I'm going to take 2 divided by 3. 2/3 doesn't reduce, so I'm going to leave it as plus or minus 2/3. Then I'm going to take 2 and divide it by 5, plus or minus 2/5. Again, does not reduce, leave it alone. And last one, 2 divided by 15. 2 divided by 15, plus or minus 2/15. Oh, man. These, right here, all of these are your possible rational zeros. So all of these, keep in mind, this is +1, -1, +1/3, -1/3, all the way through. So 1, 2, 3. So technically, we have 16 possible answers. When we do problems that involve this, we're going to pick the easy ones to work with. I'm not going to take 2/15 and use it first. You'll see how we're going to use it on the next slide. So on the next slide, we're going to take these possible answers and we're going to start guessing to figure out which ones are actually factors. So let me copy that. I'm going to slide to the next slide. Oh, please paste. right, so here's all of my possible factors that I just copied from the last slide. So we're working with the same problem. This hasn't changed. So we found the possible rational zeros. Now we're going to test them using synthetic division. Again, we're not going to use synthetic division with 2/15 unless we absolutely have to. I'm going to pick the easiest ones first. So when I use synthetic division, I'm definitely checking the 1 and the 2 first. Hopefully we'll find one before that works. So we're going to use synthetic division. When we use synthetic division, we want to have these numbers across the top for our coefficients. So we're going to use the original.
Do you want us to write that down too?
What? This, you have this on the last slide, so you don't have to copy it back. And then this is where things get kind of interesting. Oops, because I can't draw straight lines. So my coefficients are going to be from the original, so 15, 14, -3, -2. Those are the coefficients of the original problem. Where things get kind of difficult for some students, we have to decide which numbers on this magical list we want to pick to use. Like I said earlier, we always want to pick the simpler numbers, so I'm either wanting you to tell me to use +1, -1, +2, or -2. Which one do you think is going to be a factor? There's no wrong answer. You think 2 is going to be an answer, so we're going to check 2. Again, I don't know. It's a possibility. It may or may not work. So when I use synthetic division, remember everybody's favorite synthetic division, the first number always comes down. And then we're going to do what to get the middle? How do we get this middle number? Multiply. I'm going to take 2 times 15, whoops, which is 30. Then I'm going to add, what's 30 plus 14? Oops, 44. Then I'm going to multiply to get the middle. 44 times 2, 88. 88 minus 3 is 85. 85 times 2 is 170, which gives me 168. Did I get a remainder of 0? No. That tells us that on this list, 2 that we just plugged in, 2 is not a factor. It was a possibility, but it wasn't because we didn't get a remainder of 0. So guess what we're going to do? We're going to pick a different number on our list. What you do? So we're going to repeat this until we get a number that works for us. So I'm going to go back, by the power of technology, I can do this. And we're going to pick a different number. Pick 1. Sure, we're going to pick 1 this time.
But I ain't writing it down.
We're going to bring this first number down. Then we're going to multiply. 15 times 1 is 15. 15 plus 14 is 29. 29 times 1 is 29. -3 plus 29 is 26. 26 times 1 is 26. Do I get a remainder of 0? No. So guess what? We've now found 2 that aren't factors. We're about to either erase or go to a different spot. That's why I gave you the whole page. And we're going to pick another one. What number do we want this time?
You choose. Where are we getting the numbers from?
We're picking numbers off this list. So we've done 2, we've done +1. My suggestion is we do -1. Hint, hint, I would always try 1 or -1 first. Because we're learning. We haven't done anything wrong. You could pick up the wrong answer. You have 16 possibilities of numbers to use. You just happened to pick 2 wrong ones first. The odds were not in your favor.
-1 is it.
Aha, so Tori's telling us the -1's it. She's working ahead. So let's go ahead, I'm getting distracted. So negative 1 times 5 gives, negative 1 times 15 gives us negative 15. 14 minus 15 is negative 1. Negative 1 times negative 1 is positive 1. Negative 3 plus 1 is negative 2. Negative 2 times negative 1 is 2. And we got what we wanted. So we wanted a remainder of 0, and now we have it. What that means is this right here is a solution. And conveniently, we've made our lives easier. Now that we factor this out, we have a smaller version of our problem because we factored out the negative 1. We now have 15x squared minus x minus 2 equals 0. Now we have a quadratic. Granted, we could, if you were feeling up for it, keep factoring using synthetic division to find other answers. But keep in mind, there are 16 possibilities, and only 3 of them are going to work. The easiest way is to find one, take this that you have now, which is a quadratic, use your asterisk to factor it.
So most of the time, would it be like numbers that's not the fraction?
Yes, I've planned it that way. So there's one question like this on your final, which is why we're covering it. I promise that it's going to be a whole number.
Great.
I'm trying to work with you. So my suggestion would be to try your whole numbers. I would start with the smallest one first, which means really you're only going to have to do a few of them. So if I factor this using my asterisks, I have 15 in the top left, top right, negative 1 in the bottom middle, and be careful, the top middle you should have negative 30 because you're going to take negative 2 times 15. If you can't get it to factor, you probably didn't multiply A times C to get that top.
So negative 6 and positive 5.
Negative 6 and positive 5. We must check to see if we can reduce. Here we can reduce both sides. So 15 divided by negative 6, they're both divisible by 3. So I get 5 over negative 2. The other side's divisible by 5, which is 3 over 1. Oh, I should have wrote this somewhere. So now I've factored this into 2 sets of parentheses. I'm going to have 5x minus 2 and 3x plus 1 as my factors. What do you think our next step's going to be? Set them both equal to 0. So 5x minus 2 equals 0 and 3x plus 1 equals 0. Well, let's see, add 2, divide by 5, so x equals 2/5, and x equals negative 1/3. Notice these 2 answers that I just found are on my list. There's my 1/3, there's my 2/5. Would they have been beautiful things to plug into synthetic division? No, but we factored them, it wasn't too terrible, was it? The tricky thing is, when you write your solutions, you must include this in your answer. So this is a solution. So down with your answers, I want you need to add in that x equaled negative 1. We found that one up here with the synthetic division. So biggest problem I foresee is writing that final answer down there. So don't forget, whatever you took out with synthetic division goes down to become one of your answers.
So there'll be at least 3 answers.
Most of the time 3.